Hello everyone. Okay, so in this video we are going to be looking at problems with logs. So we're going to be solving problems with logs and exponentials. So these are typically section B questions. So they're the long questions of the Junior Cert. So I'm going to be going over a few examples of them. So it's crucial to apply your understanding of exponential and logarithmic functions to practical situations. Various real-life scenarios can be represented through these mathematical concepts. So, logs and exponentials, they're used with a myriad of different things. A real-life example, so like compound interest, exponential growth and decay, the Richter scale for earthquakes, decibels, depreciations, and doubling time and half-life of elements. So, when addressing these problems, including word problems, there are several steps to follow. So, same goes for every word problem we do. We first need to identify the sought after quantity. So we need to determine the variable you are trying to find and conceptualize the expected form of your answer. For instance, if you are given the formula y equals aebt and aiming to determine a specific time, the answer to take the form t is equal to something. So if I'm looking for time, my final answer should be t is equal to blank. Identify known information. So for each part of question, the variables of variables may vary. Clearly stating the value of each variable is to discern what needs to be determined. So terms like initial and at the beginning can provide a value for time. So if they say, oh, the initial quantity of carbon-14 was 50 grams, that means, well, time was 0. So you ever see the words initial or in the beginning, time is 0. Right, then you substitute known values into your formula and you isolate the relevant variable and solve. So let's look at an example here. So a population of bacteria grows exponentially according to the model P equals 700 E to the power of 0.2436 t. So just to recall, E here is a irrational number that is equal to like 2 point something 718, I think. Blah blah blah. It's an irrational number that is found on our calculator. So where t so 700 e to the power of 0.2436 t, where t is measured time in minutes. What's the initial size of the population? So we see the word initial. So that means t is equal to 0. So part 1 is p equals 700 e to the power of 0.2436 to the power of 0. P is going to equal to 700 times e. 0.2436 times 0 is going to be 0. Anything to the power of 0 is 1. So that's going to be 700 times 1. Therefore, P is equal to 700. So the initial value is going to be equal to 700. That is the initial value. Right, part 2. What's the size of the population after 10 minutes? Well, after 10 minutes, t is going to be equal to 10. And we just need to sub it in. P is equal to 700 e to the power of 0.2436 times 10. Put that into our calculator. And we get... So this is how you get e in your calculator. So if you get e in our calculator is... So I'm going to type this in. So 700... And E then is down here. It's this little red letter here next to, it's next to pi down here. So we click alpha to access that. So 700e to the power of 0.2436 times 0 equals 700. And then, sorry, we're looking at part 2. T is equal to 10. Equals 7,999.068. So the population is going to be 7,999 roughly. Right. Perfect. Let's look at the next question here, the final one. Find to the nearest minute the time which the population will have grown to 2,100. So, So P is equal to 700 e to the power of 0.2436 t. We want to find now when the population is equal to 2,100. So my P is equal to 2,100. 700 e to the power of 0.2436t. Divide both sides by 700 because I want my exponent on its own. So I have 30 equals e to the power of 0.2436t. So I could convert this to log form or use the log of both sides methods. So e is my base. My power is equal to 0.2436t. And my answer or my argument is equal to 30. So I could write that as log base e 30 is equal to 0.2436t. And log e is ln. So ln 30 equals 0.2436t. Divide both sides by 0.2436. ln is equal to, left hand side is equal to ln divided by 0.2436. And you'll get here t is roughly equal to 13.96 years. And then I think we can round up here. T is going to be roughly equal to 14 years. So my, I'll say 14 minutes, not years, minutes. Don't know why I said years, minutes. That's what we're working with. 14 minutes. Right, let's look at next problem. So the radioactive substance iodine 131 is used in medicine to measure the liver and heart disease activity and in treatment of certain cancers. It has a half-life of 8 days. So essentially what half-life is in terms of like chemistry, it just means if you have a radioactive material, it just loses energy slash matter, right? And half-life just means if it has a half-life of 8 days, that means it has half the amount it has after every 8 days. So every 8 days, it decreases by a half. So if you started with 40, after 8 days, you'll have 20. Then another 8 days, you'll have 10. Then another 8 days, you'll have 5, 2.5, etc. It has a half-life of 8 days, i.e. the quantity of iodine 131 decays by a factor of 2 in 8 days. A hospital purchased 30 grams of the substance. In 8 days, 15 grams remains. The decay can be modelled using the exponential model. Q equals A e to the power of bt, where A, B are constants and T is measured in days. Q is the quantity of the substance. Find the constants A and B. So, first of all, let's look at the initial quantity. 30 equals Q. And t is going to equal 0. So 30 is going to equal to a, e, b to the power of 0. 30 equals a, e to the power of 0. Anything to the power of 0 is 1. So I get 30 is equal to a. Second one here. I know q. In 8 days, q is going to equal 15. So q equals 15. T is going to equal to 8. So 15 equals a, e to the b times 8. I know what a is. A is 30. So 15 equals 30, e to the 8b. Divide both sides by 30. A half equals e to the 8b. Then I can convert this to log form or take log of both sides. So that's going to be ln, because log base e, of a half is equal to 8b. And b is just going to equal to ln a half divided by 8. And that's my answer there. Right? And I think if you put that into your calculator, we'll round it with 2 or 3 decimal places. It'll usually ask you what to do it to. So I have ln a half equal divided by 8. So I get b is equal to minus 0.08664. Something like that. So I've solved for A and B. What's the quantity of the substance that remain after 20 days? So Q equals AEBT. Well, I know A is 30. I know B is minus 0.08664. I don't know what T is. So let's sub it in. Q equals 30 E to the power of minus 0.088, oh sorry, just 8664 times 20, because sorry, so time is 20. We want to find out how much is after 20 days. Minus 0.08664 times 20. Put all of that into your calculator. You should get, so I'll show you here. There's my calculator, so I'm going to put in 30e to the power of minus 0.08664 times 20. And I'm going to get here, the quantity remaining is going to be equal to 5.3 grams, roughly. Approximately 5.3 grams. Then finally, find the time taken for the substance to decay to 1.49 grams. So I am now looking for time. Right? So I have time is equal to t. I know what time is. I know my quantity has to be 1.49. A is equal to 30 and B is equal to minus 0.08664. So I know 1.49 equals 30 times E to the power of minus 0.08664 t. Then what I can do is divide both sides by 30. So 1.49 over 30 equals e to the power of minus 0.08664 times t. Convert to log form, so log base e, or ln, of 1.49 over 30 is equal to minus 0.08664 t. Divide both sides by minus 0.08664. Divide both sides by that. We should get t is roughly equal to, so open back up the calculators here. So we're going to have top part of my fraction. ln is 1.49 all over 30 is all over minus 0.08664. I just double check that is the answer. Yeah. Then it goes equals, and I get time is roughly equal to 34.65 years. And yeah, that's it. So 34.65 years, something like that. Usually questions would specify if you're rounding or nearest year, etc. Right, let's look at some more examples now. So the radioactive isotope technetium-99m is utilized in medical imaging to examine organs and tissues. A hospital initially possesses 40 milligrams of technetium-99. After 12 hours, only 5 grams of the substance remain. Use the exponential decay model. Exponential decay model A times e to the b t determine the value of A and B. So t is going to be equal to time in hours. So I know, first of all, initially, the quantity is going to be 40 when time is equal to 0. So I have 40 equals A to the e to the b times 0, which is going to be 40 is equal to A times e to the 0, which is 40 is equal to A times 1, which is A. So 40 is equal to A. Gorge. Next one, I have the quantity is equal to 5 when time is equal to 12. So 5 is equal to 40 E B times 12. No, sorry. Yep, that's it. So divide both sides by 40. 1 over 8 equals e to the 12b. ln e, ln 1/8 can equal 12b. Divide both sides by 12. ln 1/8 divided by 12 is equal to b. And b is going to be equal to, put that into your calculator. You should get So we're just looking for, let me drag this over here, ln 1 over 8 all over 12. And I get b is roughly equal to minus 0.173. Right, gorge. Right, let's look at the next one here. So, a research facility acquires 100 grams of radioactive material. After 9 days, only 12.5 grams of the substance still remain. Employing the exponential decay model, Q is equal to A times E to the BT, calculate specific values for constants A and B. So, at the start, he had 100. So, initially, Q is equal to 100 at T is equal to 0. So, 100 equals A, E, B times 0. 100 equals A to the E to the 0. 100 is going to equal to anything to the power of 0 is 1, so A times 1 is A. And then find what A is, let's find what B is. I know I have 12.5 grams after 9 days, so T is equal to 9. Right, so we specify time is in days here. So time in days, so 12.5 is equal to 100A B times 9. 12.5 divided by 100 is equal to, that's an E here, sorry, is equal to E to the power of 9B. Convert to log form, so log base E, which is ln, of 12.5 over 100 equals 9B. B is going to equal to ln 12.5 over 100 divided by 9. Put that into our calculator. We get so we're looking for 12.5 over 100 divided by 9. Divide all that by 9 anyway. You're going to get B is roughly equal to minus 0.231. Right, again, they'll usually will specify if you need to round up or anything further. Right, okay, let's look at some exam questions now. So this is from the 2013 paper, leaving us at high level. So scientists can estimate the age of certain ancient items by measuring the proportion of carbon-14. So we're bringing a junior cert history here. Carbon-14 relative to the total carbon in the item. The formula used is Q equals E to the power of, so this actually is to the power of, if it's not clearly indicated there, minus 0.693 T all over 573. Where Q is the proportion of carbon-14 remaining and T is the age in years in the item. An item is 2,000 years old. You use the formula to find the proportion of carbon-14 left in the item. Well, T is going to be equal to 2,000. So the quantity is equal to E to the power of minus 0.693 times 2,000 all over 5,730. So put that into our calculator. So I want E to the power of a fraction. So that'd be minus 0.693 times 20 all over 4,730. You're going to get the quantity remaining is going to be 0.9975. So that is the proportion of the carbon remaining, 0.9975. The proportion of carbon-14, sorry, no, I'm blocking all my answers here, so sorry. The proportion of carbon-14 in an item of food an item found at Loch Bura in County Offaly was 0.3402, so it was 34% of the carbon-14 remaining in this item. Estimate correct the two significant figures, the age of the item. Well, Q is going to equal to 0.3402. Right, so 0.3402 is equal to E to the power of minus 0.693t all over 5, 7, 30. Take the log of both sides, or you can just convert to index form. It doesn't matter. Now, I'm just going to take a log of both sides. I'm cautious. I haven't done it this video. So, remember, you can just convert to index form. There is no pressure, I suppose, to do one certain way. So, whatever way you find the easiest. So, I have log 0.3402 equals minus 0.693t over 5, 7, 30 of log e. Then I need to get t on its own here. So I need to multiply by 5, 7, 30 to get rid of the fraction here. And I need to divide by minus 0.693, and I need to divide by log e to get what t is. So again, we're just doing opposites here. And if you put that absolute behemoth into your calculator now, we get, so log, so we're using a natural log here, so log 0.3402 times 5730 divided by minus 0.693 log e. And that should be equal to 8915, but it says the two significant figures. So we take the two first figures here. So it'd be 8,900 years. And that's the two significant figures there. So the item is 8,900 years of age. All right, let's look at some more questions now. So we have, I think, 3 questions left. So this video might be a bit long, so I do apologize. So 2022, so students asked to memorize a long list of digits and then write down the list sometime later. The proportion p of the digits recalled correctly after t hours can be modeled by the function pt equals 0.82 minus 0.12 ln t plus 1 for 0 to 12, for t 0 to 12. Find the proportion of digits recalled correctly after 3 hours according to this model. Give your answer correct to 2 decimal places. So t is equal to 3. So we sub it in. P is equal to 0.82 minus 0.12 ln 3 plus 1. Put that into your calculator. You should get 0.82 minus 0.12 ln 4. And we're going to get P is equal to 0.65. I said 2 decimal places, 0.65. There you go. Gorge. Right, okay, let's look at part B. So it says how many errors will exactly 55% of the digits be recalled correctly? So remember, we're dealing with proportions, so 55% is the same as 0.55. So 0.55 is equal to 0.82 minus 0.12 ln t plus 1. So we're looking for how much time will pass before he will recall 55% of the digits given to him. So t is going to equal t. We don't know what that is, so we want to solve for t. So 0.55 minus 0.82 equals minus 0.12 ln t plus 1 minus 0.27 equals minus 0.12 ln t plus 1. Divide both sides by minus 0.12. We're going to get 9 over 4 is equal to ln t plus 1. Then converting this to index form. So remember, ln is equal to log e. So my base is e, my argument is t plus 1, and then my power is going to be 9 over 4. So e to 9 over 4 is equal to t plus 1. T is going to equal to e to the power of 9 over 4 minus 1. And if you put that into our calculator, ladies and gentlemen, you get, so e to the power of 9 over 4 minus 1 equals t is equal to 8.49 years, hours. 0.849 hours. So little Jimmy here, wherever his name is, they memorize a bunch of numbers, and they know after eight something hours he can recall exactly 55% of them. So I skipped part C and D from this exam question because they involve calculus. I haven't done that yet, but let's look at part E. So if we learn a skill and don't practice it, how well we can usually do it decreases over time. Like mathematics, girls. Take the hint. So for example, if you learn to play the guitar and then don't play the guitar for a number of months, you will probably not be as good playing the guitar the first time you tried it. That makes sense, doesn't it? This effect can be modeled with the following equation. A equals B times t plus 1 to the power of c, where a is the measure of how well the skill can be done at certain times, t equals 0. B is the measure of how well the skill can be done t months later. Without practicing, c is a constant. So write c in terms of log a, log b, log 10 of a, log 10 of b, and log 10 of t plus 1. So I want to get c on its own. So what they did here, they took the log of both sides, right? So they used log of both sides methods to solve this. So they took the log of base 10 of both sides. So log base 10 of a equals log of base 10 of b times t plus 1 to the power of c. So I'm going to have log base 10 of a equals, I can rewrite this as log base 10 of b plus log base 10 of t plus 1 to the power of c. And I have this power up here, and I bring it down in front. So I'm going to have here log, so remember log base 10 is written as log a equals log b plus c log t plus 1. And it's asking me to leave it as like log a, like log b, log t plus 1. So I'm very cautious to leave it like that. So I'm going to have log a minus log b equals c log t plus 1. Divide both sides by log t plus 1. And that's there. So c is equal to log a minus log b all over log t plus 1. There's my answer there. So a student got 80% on a guitar exam. After 2 years of not playing it, he got 47% in the same exam. Find the value of c in the model above, correct to 3 decimal places. So this is a fun one because we can actually use our answer here, sort of. So A is the measure of the skill at a certain time. So he measured it at 80% proficiency, right? Then 2 years later, he measured at 47% proficiency. So, and then T is the time as the might has passed. So A is the initial, B is how well you did after time has passed, and T is how much time has passed. And I found what C is by using this formula. So I have C is equal to log A. So what's his initial? Well, it was 80%, so 0.8 minus log B is now 0.47 because B is just how proficient you are after amount of time, and then all over log t plus 1 after 2 years, so it would be 2 plus 1. So that would be log 3. Right, so put them in the calculator. You're going to get, so log 0.8 minus log 0.47 all over log 3. And we get C is equal to 0.484. That is what C is equal to. How fun was that? Right, we just have 2 questions left. Let's power through. So 2021 question here. So a cup of coffee is freshly brewed at 95 degrees Celsius. The temperature T in degrees centigrade over the coffee... sorry. The temperature T in degrees centigrade of the coffee as it cools is given by the formula here. A times e to the power of minus 0.081 t plus 20, where a is a constant and t is the time measured in minutes when the coffee was brewed. Show that a is equal to 75. So when it's freshly brewed, it's 95 degrees, i.e. its initial time is 0, so t is equal to 0. So the temperature, right, at when time is 0 times e to the power of minus 0.081 times 0 plus 20. So 95 equals a to the e to the power 0 plus 20. 75 is going to be equal to a, because anything to the power 0 is 1. A times 1 is a, plus 20 is 75. Bring over the 20, you get 75. Explain what the 20 in the formula represents in context of the coffee cooling. So, what's that mean in context of the coffee cooling? So, it just means, I think, it's room temperature. I think that's what it means here. It just represents the temperature of the room, because even if time gets astronomically large, right? If this cup of coffee was sitting there for 1,000 years, right, it will never get below 20 degrees. So it is the room temperature, because if T gets really, 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 really big here, E here will get really, 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 really small. So this is all limits and stuff, right? But the 20 here represents the room temperature. Like, so the coffee will not get colder than 20 degrees, because it can't really get colder than the room it's in, you know? Find the decrease in the temperature of the coffee 10 minutes after brewing. Give your answer correct to the nearest whole number. So, and T is measured in minutes. Okay, gorge. So, temperature is equal to 75 e to the power of minus 0.081 times 10 plus 20. Let's put that in your calculator. You get, so 75 times e to the power of minus 0.81 or minus 0.081 times 10 and plus 20, and it said round your answer to the nearest whole number. So I'll show you here. So I have 53.36, but it says round to the nearest one, so it's going to be roughly equal to 53 degrees Celsius. So after 10 minutes, well, it says find decrease in temperature. So the temperature after 10 minutes is 53 degrees. So its decrease is going to be 95 minus that. So minus 95. So 41 degrees. So there's decrease in 41 degrees Celsius. There. The ideal temperature to drink coffee is 82 degrees. Find the time to the nearest second that it takes for the coffee to reach this temperature. So T here is going to equal 81. We're looking for time. So let's sub everything in. So 81 equals 75 e to the power of minus 0.081 t plus 20. So I need to get this exponential stuff on its own. So bring the 20 over, subtract it. I get 61 equals 75 e to the power of 0.081 t. Divide both sides by 75. I get 61 over 75 equals e to the power of 0.081 t. I can just get the log of both sides, or just convert it to log form. So log base e of 61 over 75 equals minus 0.081 t. Divide both sides by 0.081 minus 0.081. That gives me t. And time is going to be equal to ln equals 61 over 75 minus 0.081. And we're going to get here time is going to be roughly equal to, when you put down your calculator, 2.55 minutes. But saying round to the nearest seconds, I was being a little sneaky little snake. So 0.55 minutes. Multiply that by 60. So we're going to get 2 minutes and 33 seconds when you put that into your calculator. So after 2 minutes and 33 seconds, the coffee is its ideal temperature. Right, then the last question, thank goodness, it's from 2014. So that's meant to say Kieran. I have to go fix that. So Kieran is preparing food for his baby and must use cooled boiled water. The equation y equals ae to the power of et describes how the boiled water cools. In this equation, t is the time in minutes from when the water boiled. Y is the difference between the water temperature and the room temperature. So y is the difference between the water temperature and the room temperature. A and E are constants. So the temperature of the water when it boils is 100 degrees Celsius, and the room temperature is a constant 23 degrees. So write down the value of the temperature y when the water boils and find the value of A. So remember, y is the difference. So it's going to be 100 minus 23, which is going to be equal to 100 minus 23 is 77. So the difference is 77. That's going to be a to the e, b, t. Now, this is initially, so t is going to be 0. Right? So when the water just boiled, no time has passed. So 77 equals a to the e to the 0. A is going to equal to 77. So A is equal to 77 there. After 5 minutes, the temperature of the water is now 88 degrees Celsius. Find the value of K. So remember, Y is the difference. So it's 100 minus 88, which is 12. So the difference is only 12. Sorry, that's wrong. So it's the difference between the temperature of the water and the room. And the room is 23 degrees. So 88 minus 23 is going to give me 65. So the difference is 65. I know A is equal to 77. So e to the k, and after 5 minutes, and then see, time is in minutes, I'm pretty sure. Yeah, pretty sure the time, time's in minutes. Yep. 5, get what k is, divide both sides by 77. So 65 over 77 equals e to the power of 5k. ln 65 over 77 equals 5k. Divide all that by 5. I get k is equal to, put all of that into your calculator. So ln 65 over 77 all over 5 is equal to k. K is going to be roughly equal to minus, so it says to 3 significant figures, so it'll be minus 0.0339. So remember, significant figures, we only look for the first 3 non-zero numbers. So k is equal to minus 0.0339. Right. Kieran, right? Kieran prepares the food for his baby when the water has cooled to 50 degrees Celsius. How long does this take? Correct to the nearest minute. So the water is now 50 degrees. So y is equal to 50 minus 23, which is 27. So 27 is equal to 77 e to the power of minus 0.00, no, just 0339 t. We want to find out how long it takes. Divide both sides by 77. So 27 over 77. Ding, ding. Equals e to the power of minus 0.0339 t. So I'm going to take the log of both sides. So I'm just switching it up. So just keep reminding you can do both ways. So log of 27 over 77 equals log of e to the power of minus 0.0339t. I can bring all of this in front. And I have log 27 over 77 equals minus 0.0339t log e. I'm looking to get time on its own, so I'm going to divide both sides by minus 0.0339 log e minus 0.0339 log e. That's going to cancel here and that's going to cancel here. So t is going to be equal to all of this. So let me just rewrite that there to be a bit neater. So t is going to be equal to log 27 over 77 all over minus 0.0339 log e. Put all of that into your calculator. (27) all over that, all over minus 0.0339 log e. And I'm going to get time is equal to 71 minutes. So it takes 71 minutes for the it takes 71 minutes for the water to cool down to 50 degrees. Gorge. Right. Finally, this one here. Use your values of a and k, sketch the curve. So we want to sketch this curve. So we're going to be using our calculator to get our values. So we want to set up a table of values. So set up tables, we click 3, put in a function. So my function is 77 e to the power of minus 0.0339, I believe, is it? Minus 0.0339. Yeah, t. And I don't know what t is. We're mapping out t. So t is going to be my input. That's going to be my x value. So we need x. So click that there. Gorge. So I'm starting from 0. I'm ending at 100. And I'm going to go up in tens. So there we go. When x is 0 is equal to 77. So that's going to be like roughly here. And when it's 10, it's 54. So after 10, it's 54. So it's going to be around here. 54, just there. After 20, 39. There. 30, it's going to be 27. So that's around here. 40 is 19. That's going to be... Sorry, what was it? Oh, 30 was 27. Sorry, 27. 20 is 39 there. 30 is like 27. 40 is like 19. So that's going to be like roughly around here. 50 is around 14. So that's going to be just here. 60 is 10. 10 and 7. So just here. 80 is 5. And 90 is like 3. That's right here. And 100 is like 2.5, which is around here. So there you go. And that's it. Plotted out there. So it's a negative exponential. So it's getting smaller and smaller. Closer down. Right. And that's all they're asking us for here. I'm out of breath. God, this video is ages. And I hope it was some help to you guys. You're probably not going to watch it, but I'll catch you guys later. Bye.